Hi there! Welcome to a new physics lesson filled with discovery and exploration. Today our topic is work. We crack open chapter 5. So let's jump into it. What is work? And it's strange that we have this quantity, this variable in physics called work. We use that term every day. I have to go to work. I have homework. It takes work to become a good athlete or to be anything. And um, and so today we're gonna talk about work and how we can quantify work in our universe. And so first of all, definitions. What is work? Well, if we were to define it, work is what we call the bridge between force and energy. It's what we can also say that work is a transfer of energy between perhaps a force or perhaps between objects. And so here's the equation for work. Work, W, is equal to a certain force that's exerted on an object over a certain displacement. So when we push a box or a chair or a car a certain displacement, and that's a key word there, displacement, we are going to have some kind of work. And of course, sometimes this exertion of work can be at a diagonal, and so we're going to take the cosine of the angle of whatever that force and the displacement is. Usually it's going to be on a flat surface for our cases, so it's 0 degrees, but it could be at an angle. And so the unit for work is the joule, which joules are Newton times meter. Okay, Newton's times meter, and it makes sense, right? Because the equation is force times the displacement. Force is measured in newtons, displacement is measured in meters. And so Newton times meter is what we call the joule, named after the great James Joule. And we have a whole bunch of different forms of energy, or different forms of transfer of energy. And so we're going to take a look at that in just a second. But here's some counterintuitive points about work that we have to discuss. First of all, that because part of work requires a displacement, if I were to push a box forward and backward, or to lift the box off, to lift a box or a heavy object up and then place it in the same spot that it originally was, no net work would be done on those objects because there is no displacement. Okay, so if there is no displacement, if the object returns to the same place that it originally was at, there would be no displacement. And second of all, second important counterintuitive result or thing to think about is that forces, when we have a force that is perpendicular to the displacement, that object actually does no work on that object. So for example, here's our example here. If I'm pushing an object across the floor, the normal force and the gravity, which are pointing in they're pushing and pulling the box in the y dimension, but I'm pushing and pulling the box in the x dimension. Because it's perpendicular, I do not factor in force or gravity into our equation. No work is done on an object when there's forces that are perpendicular to it. Okay. And so kind of just to sum things up, work is whenever there's a transfer of energy. And in order for there to be work done on an object, there must be a force that pushes or pulls an object a certain amount of displacement or disturbance from its original position. And so when we're moving an object, the force and displacement have to kind of be in the same direction. It's not direction, but the same dimension, same plane. Or they must be parallel to each other. They must be going into the same direction. And so work also has a sign. It is what we call a vector. And so how do we determine the sign of work? Well, kind of like acceleration, if the force of the object and the displacement are in the same direction, so for example, if I'm pushing a box and the box is moving in the same direction I'm pushing it, I'm going to have positive work done on the object. I'm going to have positive work done. And so it's going to cause my box to possibly speed up. It's going to accelerate my box. However, if my force, let's say the box was already moving, and let's say I was at Ice Palace, there's a huge cone that's moving thrown my way, and I use a force against the direction that that cone is moving, or my force is opposite of the displacement, the object will be slowing down and my work will actually be negative. Okay, so that's work in a nutshell, our introduction to work. Thank you for joining us, and see you next time.